So in lesson 3-4, titled Solving Matrix Equations, maybe why we had to learn about matrices might start making sense. This looks familiar, right? You learned in lesson 3-1 how to solve these by graphing or substitution or elimination. Well, we're going to show you one other way to do it by matrix, and not because um, matrices are necessary for these equations, but we're about to start doing equations that have x's, y's, and z's in them. And even though you can do equations that have x's, y's, and z's in them by hand, by doing substitution and elimination and all that, it's really tedious and takes a lot of paper. So we're going to learn how to do solve them using a matrix on the what we call 2x2s. These are 2x2s. And so when we get to the 3x3s, it'll be old hat by the time you get there. Okay, so the first thing that you need to be able to do is change this system into a matrix equation. These capital letters right here each stands for a matrix. So we call this one matrix A, and it's called matrix A is called the coefficient matrix. And where did the numbers come from? The 2 came from the coefficient in front of the x. The 1 came from right here. It was the coefficient in front of the x, so the x's went first. Then the y's went second. The 3, notice the -4, the sign comes with it. That's the number one mistake people make when they write this matrix. So the 3 comes with it, and then the -4. And those 4 numbers right there go together to make what we call the coefficient matrix, because they are numbers that are the coefficients of our variables. Then we have our variable matrix, and this is just going to be the matrix that contains our variables. Our variables right here are x's and y's. So the x's are first. They're listed first. The y's are listed second. Those are the y's. And then we have our equal sign, and then we have our constant matrix. And if you don't understand why these are constants because they're numbers that are not associated with the variable. So as we plug in values of x and y, and we do the multiplication right here, that 7 staying a 7. Why? Because it's not associated with an x or a y. So it's a constant 7. So, and that's what we're calling matrix B. So setting them up is the first step. Always the first step is being able to create this matrix equation and all of the vocabulary, okay? So there's a multiple choice question on your test where I give you this problem right here, and then the question says, which of the following is the matrix, the coefficient matrix? And I give you this one to pick from, I give you this one to pick from, and I give you that one to pick from. And you simply have to know which one is called the coefficient matrix. Or I might say, which one is the variable matrix? And you have to pick, which one is the variable matrix. So be sure you get these vocabulary words down. You don't want to miss an easy test question because you didn't learn the meaning of a word. Okay, so be sure you do that. And then, of course, on the Springboard book, there are definitely problems that you can try. There we go, right there. So you should practice right now taking these and rewriting them as your matrix equation. Okay, and your matrix equation will be your coefficient matrix, then your variable matrix, set it equal to your constant matrix. So see if you can do those right now. All right, back to what I was doing. All right, now solving these is no harder than solving this problem right here. So let's just take a break right quick and go through this one. So hopefully you're excited because you're like, I know how to solve that one. And somebody's going to say it's x equals 4. Okay, you're absolutely right. The answer is x equals 4. Let me get rid of the rainbow. It is absolutely x equals 4. But some of the details that you're missing out in here is why you don't really understand what's happening over here. So let's talk about the details. Some of you say, oh, I know what the details are. I just have to divide both sides by 3. You're absolutely right. We are going to divide both sides by 3. And then we say often that that cancels out. We'll talk about that word in just a second. And that leaves us x equals, and 12 divided by 3 is 4. Okay, I agree with all of what you just said. Or all of what you just thought. But what I want to do is I want to look at this in a little bit more formal mathematical way. Okay, so the reason that we divide both sides by 3 is because this problem right here says 3 times x, and multiplication is and division is what undoes multiplication. So that's what we've taught you, and that's right. But really, another way to look at it is the reason that we divide by 3 right there is because what we're looking for is an x with a coefficient of 1. That's what we really want. Right now, our x has a coefficient of 3, and what we really want it to have is a coefficient of 1. So there is this thing called the identity property, and we did this back when we were doing Are You Ready for Unit 1? This was one of the questions. Do you remember the question about the multiplicative and the additive inverse? Okay, so a lot of you said we would divide by 3, but I'm going to ask you, what would happen if instead of dividing by 3, I multiplied by 1/3? Now, back in that review, we learned, or we reminded you that 3 and 1/3 are multiplicative inverses, because why? When you multiply them together, what do you get? You get 1, because when you multiply 1 times 3, you get 3. When you multiply 3 times 1, you get 3, and 3 over 3 reduces down to 1. So really what we're doing, or another way of saying divide by 3, is to multiply by 1/3. The multiplicative, I love that word, the multiplicative inverse. The multiplicative inverse of 3 is 1/3, because 3 times 1/3 equals 1. And that is the multiplicative identity. Okay, 2 numbers that multiply together to equal 1, they're multiplicative identities. Okay, it's a multiplicative identity. So really what we did, instead of saying we divided both sides by 3, we could also say we multiplied both sides by 1/3. 12 over 1 times 1 over 3 gives you 12 over 3, and 12 over 3 reduces to 4. So you may be thinking, why are you making this so hard? I'm not making it hard. I'm just explaining to you these vocabulary words because this is what's going to happen over here. What I'm going to do to make this coefficient right here, this coefficient matrix, because I'm trying to get my variables by themselves, to make this coefficient matrix go away, it doesn't really cancel out. What I want to do is change it to a 1. And the way I change it to a 1 is to multiply it by its inverse. It's multiplicative inverse. So a times its inverse is going to equal what we call 1. This is 1 as a matrix. So when we get this right here, a diagonal of 1s with 0s, that's the same thing as saying that my coefficient right here is 1. I'm going to get 1 right there. That is what 1 looks like as a matrix. And if it was a 3 by 3, it would have 1, 0, 0, 0, 1, 0, 0, 0, 1. Have a diagonal of 1s. That's a 3 by 3. And again, if it was a 4 by 4, it would have a diagonal of 4 1s, and it would be 0 everywhere else. Okay, so that's what those are called identity matrices. Okay, and then the identity matrix is just simply a way of writing a 1 in front. It's like a coefficient of 1. Okay, so when I'm solving this matrix equation right here, I multiply both sides by the inverse of A, and this is how we write the inverse of A. I get the answer. I multiplied both sides of this equation right here by the inverse of 3. I multiplied it by the inverse of the coefficient, and my my problem simplified down, to the answer. Okay, so this ended up being my answer. So by multiplying both sides of the equation by the inverse of the coefficient. See all these rich vocabulary words? By multiplying both sides of the equation by the inverse of the coefficient, we got a 1 in front of x, which is what we wanted. 1x is equal to 4. So we're going to do the same thing right here. We're going to take this math problem and we're going to multiply both sides by the inverse. And so we're going to multiply a times a prime, and we're going to multiply, I think we have to do a prime times b. We'll look at that in just a second. When we do, these two are going to leave us a 1, that identity matrix, in front of our x, in front of our, and then this is going to be our answer matrix. This is going to be our answer right here. This is going to be our answer matrix. Or it's going to be our solutions. Okay. Now, the good news is we don't have to do this by hand. You don't even have to find the inverse. That's something that you'll learn in another, I don't even know where you'll learn it, another course. The calculator is going to find your inverse for you. It's not as simple as you think. It's not just 1/2, 1/3, -1/4. That's what students think, but it's not. It's uglier than that. But or sometimes it is uglier than that. But all you have to do is know that this is what you're supposed to do. Multiply both sides by the inverse. This is what you have to understand you're doing, okay? Now, I'm going to go ahead and stop the video because I'm at 12 minutes. And I'll start the next video by showing you how to do this on the calculator.